Good afternoon, everyone. This is my first project group presentation. And this is the table of contents. These are the these are the topics that I'm going to discuss later. Introduction. Um, the OSI or Open System Interconnection Model is a conceptual framework that standardizes network communication into seven abstract layers. From a physical connection to the application, it provides a universal language of how different computer systems and devices can communicate, even with a diverse hardware and software, by defining specific functions for each layer to perform. OSI model or open system interconnection is used to visualize and simulate how computer network functions. Packet tracer simulation mode allow users to see how data moves between layers, with the ability to click and the colored boxes to examine protocol information like source, destination IP, and MAC addresses, which are handled at different OSI layers. So, OSI model is composed of seven layers. Start with physical layer, the data link. Third layer is a network, the fourth layer is a transport, and the fifth layer is a session, and sixth layer is a presentation, and the last one, the seventh layer is the application layer. The layers are part of our discussion today is from start to physical layer to transport layer. So now we will proceed to the discussion. Our first discussion which is the physical layer. Physical layer is the first layer of OSI model in charge of level transmission between different devices and support physical interfaces connecting to the physical medium and for synchronized communication. Physical layer it is assigned with most of the network physical connection wireless transmission such as infrared, Bluetooth, etc., and wired communication like cabling standard and types, connector and types, network interface card, and more as per network requirements. Physical layer also describe the mechanical and electrical functional and procedural means to activate, maintain, and activate physical connection for a bit. It is targeted at consolidating the hardware requirements for the network to enable the successful transmission and reception of data. So, physical layer is a layer that's responsible for transmitting arrow bits and over a physical medium like copper, cables, fiber optics, and wireless signals. Its purpose is to define the physical and electrical application for the transmission, handling, and the conversion of data bits into signals like electrical pulses or radio waves, and ensuring they are synchronized for accurate delivery between devices. Right? This is the services of physical layer. It physical layer converts a signal from one form to another. It's a bit-by-bit delivery, line coding that show how data is done by hardware that is converted for digital transmission. Physical layer is asynchronous serial communication are characterized by bit synchronization. Physical layer is a start-stop signaling and flow control and ease of multiplexing. Carrying sensing and collection detection that determine the carrier availability and avoid the transmission congestion problem. It's signal equalization and forward error connection. But these are the services of physical layer. Now we'll proceed to the protocols. So these are the protocols of physical layer. Like any other layer, physical layer also have a protocols, which is the digital subscriber line, the integrated service network, digital network, and for data association, universal stereo bus, Bluetooth, and controller area network, and last is Ethernet. Now we will proceed to the second layer of the OSI model, which is data link layer. When we say data link layer, this layer main responsibility is to transfer data frame between nodes over the network, and then it function for encoding, decoding, and logical organization of data bits. The data packets are framed and addressed by this layer, which consists of two sublayers, the MAC and logical link control, and the data link layer frame include the source and destination addresses, data then start signal or indicator or other related internet information to enhance communication. The data link protocols describe methods for exchanging data frames within devices over a common media. The data that we code for this layer is a frames. As we mentioned above, there are two types of there are two sublayer of data link layer, which is the MAC or media access control and the logical link control. So a data link layer is responsible for node-to-node data transfer on a single network segment and ensuring reliable and error-free transmission of data frames. Its purpose is to provide a well-defined interface to the network layer by handling an error detection and correction and regulating data flow and managing access to the physical medium. Now we'll proceed to a sub-layer, the types of sub-layer of the data link layer, which is the MAC, and the logical link control. When we say MAC or media access control is a first sublayer that used for source and destination addresses, allowing the data link layer to provide the best transmission mode and manage the data flow. MAC identify who is allowed to access the media at any one time. MAC refers to a frame structure conveyed based on the MAC addresses inside and determines its frame synchronization, which are one frame of data ends and the next one starts. MAC or media access control have two forms, which are the distributed and the centralized. When we say distributed forms of MAC, it refers to the protocols that manage how multiple devices share a communication channel without relying on a central coordinator. So instead of a single access point controlling all the transmission, each node independently decides when to transmit the data based on the set of rules. This approach is essential for scaling wireless networks where devices are often mobile and lack of central point of control. Now, when we proceed to centralized forms of MAC, when we say centralized form of MAC, the protocols in a computer networking where a single central entity coordinates and control access to shared communication medium. Now, centralized forms of MAC approach is an contrast to distributed or decentralized MAC protocols where decisions about medium access are made collaboratively or independently by individual network nodes. And now we will proceed to logical link control. The logical link control is a second sublayer that handles error checking in data flow over a network. It determines addressing and control of data link. It specifies which procedure are used for addressing station over the transmission medium and for controlling the data exchange between the originator and the recipient machine. Now we will proceed to the methods of frame synchronization of the data link layer. Uh, there are four methods of frame synchronization in data link layer, which is a time-based, character counting, byte stuffing, and bit stuffing. Time-based, when we say time-based, it is a time bounded between frames. It's a method used in the data link layer of the OSM model where the receiver distinguishes frame boundaries by expecting a specified amount of time and ideal period between frames. So this technique is typically used as asynchronous communication where a sender and receiver do not share a common continuous clock signal. It's a time bounded between frames. The major configuration of this is the new gap can be introduced or the old gaps can be lost due to the external influences. Now, character counting, when we say character counting, it's a frame synchronization method where each data frame includes a header field specifying the exact number of characters, byte, and the frames. This allows the receiving device to determine the end of the current frame and the beginning of the next one by counting the specified number of characters. Excuse me. However, this method is not commonly used today because it is vulnerable to errors, and if the counter field is corrupted, it's leading to a synchronization failure. Next is byte stuffing. When we say byte stuffing, it's a data link layer technique for frame synchronization that prevents physical control character from being misinterpreted as frame delimiters. Byte stuffing or character stuffing is where is achieved to which the sender insert an extra escape byte before any control character that appears in the actual data, and the receiver remove these escape bytes u- during the destuffing to restore the original data. And the last methods of frame synchronization is bit stuffing, where bit stuffing is when you say bit stuffing, it's a data link layer technique and also a OSI model used for the frame synchronization in a bit oriented protocols. So these are example of the laboratory exercise 3, which is the configuration of IP addresses at the subnet mask and to the host. Now we will proceed to next layer, which is the third layer of OSI model, which is the network layer. A network layer is a third layer of OSI model. It's responsible for packet forwarding, including routing. It provides services to exchange the individual pieces of data over the network between identified end devices. So, network layer is responsible for packet forwarding, logical addressing, and routing to move data between different networks. Its purpose is to establish end-to-end communication between devices or disparate networks by creating the most efficient path for data packets and managing the logical addresses like IP addresses that identify devices. Router. When we say router, it's an networking device that forwards data packets within computer networks. It performs the traffic directing function of the Internet. The Internet relies on the data packets which are conveyed from one router to another through the networks that build up the entire network until it reaches their recipient. So to router is connected to two or more data lines from different networks. When data packets comes in one of the lines, the routers reads the address information in the packet to determine the ultimate destination. Router are computers. It has an IP address which serves as a pathway finder to select the best path. Router is also considered as a layer 3 device because its primary forwarding decision is based on the information in the layer 3 IP packets, especially the destination IP address. So there are two types of router, which are the home and small office routers and the enterprise routers. When we say home and small routers, these are the routers that is most familiar type and that simply pass the IP packets between the home computers and the internet. The example of this router would be the uh, owner's cable or DSL router which connects to the internet through an internet service provider or ISP. Enterprise router. The enterprise router, when we say the enterprise router, these are the routers that are more sophisticated, that connected to the large business or ISP network, up to the powerful core routers that forwards the data at huge speed along the optical fiber lines of the internet backbone. So, what is routing? When we say routing, routing is the process of selecting the best path for traffic and network or between across multiple network. It is a performed for many types of networks, including a circuit switch networks such as public switch telephone network or PSTN, computer network, as well as in networks used in public and private transportation and such as the system or the streets, roads, and highways in national infrastructure. In packet switching, routing is a higher level decision making that directs network packets from their source towards their destination. The- towards their destination through the intermediate network nodes by a specific packet forwarding mechanism. What is packet forwarding? When we say packet forwarding is a transit of logical address network packets from one network interface to another. Using information in its routing table, a routing policy directs the packet to the next network in its journey to create an overlay network. And network hardware devices. There are four network hardware devices, which are the routers, bridges, gateways, firewalls, or switches. So these are the four hardware devices of the network layer. So, what is packet switching? When we say packet switching, it's a method of sending data by breaking it into a small packets, each of the header containing control information. These packets can travel independently across the network, potentially using different paths and are reassembled at destination. This is a core network concept. Packet tracer allows you to simulate and configure. In packet switching, it features the delivery of variable bit rate data stream and a sequence of packets over a computer network when allocates transmission resources as needed using a statistical multiplexer or dynamic bandwidth allocation techniques and data dispersed network nodes such as switches, routers, packets, or receive buffered and transmitted, resulting to a variable latency throughput depending on the link capacity and traffic load on the network. Next, we'll proceed to the circuit switching. When we say circuit switching, it's a method of establishing a dedicated reserved path between two endpoints of the duration of communication session. In circuit switching, once the circuit is set up, it remains is exclusive to that connection, which guarantees a fixed bandwidth and ideal for application like voice call. Packet tracer simulates this by creating a persistent physical or logical connection that stay active until the session is terminated. So packet switching and a circuit switching has a difference. And so circuit switching is characterized by fee per unit of connection time when no data is transferred and creates a dedicated fixed path for communication session receiving bandwidth for its duration, where each packet switching divides a data into packets that are routed individually over available paths, sharing network resources, and may be characterized by fee per unit of information transmitted such as character, packets, and messages. Oh, the main differences are that the circuit switching is a connection oriented, ideal for voice calls, and provides guaranteed bandwidth, while the packet switching is a connectionless, more efficient for data like internet, and doesn't guarantee a consistent uninterrupted path. So these are lab exercise 004, which is the routing protocol and a basic LAN configuration. Example of network layer configuration of LAN. Next is our last transport layer, last discussion, which is the transport layer. When we say transport layer, it's a fourth layer of OSI model responsible for end-to-end communication and reliable, reliable data delivery between application on different hosts. Transport layer method is of dividing the architectural protocols and the Internet Protocol suite and open system interconnection. Transport layer protocols provide a host-to-host connection, and it's responsible for transferring an information to the appropriate application process of the end devices. Transport layer purpose is to segment the data for transmission, reassemble it at the destination, and provide flow and error control to ensure data arrives completely and accurately. So as any other physical I and is as any other layer like physical layer, transport layers also have services which are the connection oriented communication, same order delivery, reliability, flow control, congestion avoidance, and multiplexing. uh, like and also like any other layer like physical layer, transport layer also have a protocols So these are the protocols of transport layer, which is ATP or Apple Transaction Protocol, CUDP or Cyclic User Datagram Protocol, or DCCP or Datagram Control Protocol, and FCP Fiber Channel Protocol, IL or Internet Link Protocol, and MPTCP or Multi-Path Transmission Control Protocol, RDP Reliable Data Protocol, RUDP Reliable User Datagram Protocol, SCTP Stream Control Transmission Protocol, SPX or Sequence Packet Exchange, and SST Structured Stream Transport, and TCP is the Transmission Control Protocol, or UDP or User Datagram Protocol, and UDP Lite. And last one is uh, microtransport protocol. So this is an example of um, uh, lab exercises number 5, which is the design of a website using Cisco Packet Tracer. So, good morning, everyone. Um, I'm going to answer this table, and I'm going to explain how I came up with this answer. So first, let's start with number 1. To be able to get the prefix length, we have to get the subnet mask and use the table. Hey, okay. Use this table. We're gonna use this table. 6, 4, 3, 2, 16, 8, 2. The camera signal stable. Another 6. 2, 1. So we have to get the subnet mask, which is 255, 255, 255, and 224. Take a 255, 255, 255 and the mass is 224. So to be able to get the free fixed length, we have to mhm, subtract the subnet mass to this number to get the binary value of the subnet mask. 255. I think I need a table. There's two table. Like 255 minus 128 equals to 15 minus 8 equals to 7, and 4 minus 2 equals to 2, 2 minus 1 equals 1. So we have 27. 27 value. Now we put put number 1 here since we use this 128, and next we can use this 64 to subtract to 127. 64 to 127. Then we have 7 minus 4 equals to 3. 12 minus 6 equals to 6. And we have 63. What's this? So 127 minus 64 equals to 63. Now let's proceed to this. Since we're done with 64, we can use the 62 now to subtract the 63 number. Let's put some 1 here. And then 32 minus 63, we have 3 minus 1 equals 3 minus 2 equals 1, 6 minus 3, and 3. So we have 31. 31. Then we can use this 16 since 31 is higher than 16. We can use 16. 16 minus 31 minus 16 equals 11 minus 6, 5. 2 minus 1, 1. So we have 15. Forget to use the subtraction symbol. So we have 15. Now we can use this number 8 to subtract with 15. 8. Then 15 minus 8 equals to 7. The 7. We can use this for another one. Sorry, it should be 1. 7 minus 4 minus 4 equals to 3. Now we have 3 value. Then subtract 3 with number 2. So 3 minus 2. Then we have 1. can use 1 from this table to subtract with 1. So that's it. We have the value of 1111111. So 8 ones. And just need to copy this. It's the same as 225 value. There. Then next, we have to get the value of this 224. Subnet mask 224. So same as this, we have to subtract 224 to one uh, to the number here that we could use. 224 minus 128. Just need to make this table small. Save some space. And 224 minus 8. 14 minus 8. 6. So 1 minus 11 minus 1. 11 minus 2. 9. And we have 96. So since we have 96, we have to look for the number in this table that we could use that um, not lower that we could use to subtract with this number 96. Since we use the number 128, we put some value of 1 here. Then we could use 64. Since this is a higher number than 64, we could use the 64 number. So 96 minus 64 minus 64. And 6 minus 4, we have 2. And 9 minus 6, we have 3. 3. Since we have the value of 32, we can use this 32 number. Sorry, I had to put 1 here. That's the values. And 32 minus 32, then we don't need this number anymore, so we can put some 0 value and 0 value and 0 value, another 0 and another 0. So as you can see, we have a binary value of the subnet, the how many 8, 16, 24, 25, 26, 27 ones. So the prefix value of this subnet mask is 27, right? 24, 25, 26, and 7. So let's proceed to number 2. To be able to get this answer of the broadcast address, we have to Again, use the network address and the subnet mask. Number one, sub two. Uh-oh. Alright. Number one. Now we will proceed to number two. I just have to copy these tables. So, we need na pala. So we just have to copy this. Cannot be copied. So I just need the network address and the subnet mask to get this answer. 172.201. 172.201.95.32. And the subnet mask is 225, 225, 225, 224. 255.255.255 and 224. So to be able to get this, we just have to sorry, use the table. Should be here. So I just need one thing. To subtract um, to be able to get the broadcast address, we just have to subtract two, two, 224. This last value of the subnet mask to 256. So 256 minus 224. Then we have 6 times 2. 6 minus 4. We have 2. Right? 2. Then 5. 5 minus 2. We have 3. Now we have the value of 32. Since 32 is just equal to this number, you have to um, get a higher value than this. So 32, just have to add addition plus 32. Then we have 64. 64. So 64, we have a 64 value. 64 minus 1, and we have 63. So the broadcast address, in question number 2 is this. Just have to copy the subnet mask, which are the 255, 245, and 245, then to the network address, which is 172.201.95 point. uh, this answer that we have, this value that we have, 63. So this is how I get this number. Now we'll proceed to number 3. Just have to copy this. Okay, fine. 172. Wait, 201.95.32. No, 63. So this is the broadcast address answer in number 2. Now we will proceed to number 3. Now to be able to get the subnet mask on number 3, we have to use the prefix length and the network address for this number, which is 10.10.78.128. So 10.10.78.128, and the prefix length is 25. Now we have a 25 prefix length. We just have to get a solution on how to get this the uh, 25 prefix length, so we can get the answer for the subnet mask number 3. Just have to copy this table. Wait. I forget to put some zero here. So so to be able to get the prefix length, which is 25, we just have to identify what number we could use to get this prefix length. So this is my answer. Since we have we already have this binary value of the subnet mask, which is 255.255.255, and the binary value of this subnet mask is 24 total number of ones. So we could add some one here, then use a zero. Since we only have one, we didn't need this number anymore. Zero and zero, and you just need one to be able to get the number at the prefix number 25 here. So 24 ones plus 1 in here. Then we have 25. So the subnet mask for this um, network address, which is 10.10.78.28, 128, is 255.255.255.1. Insert tables. Can I just need one, so 1 minus 1. So that's it. Okay, we're done. Then the answer for this is 255.255.1. So this is how I get this answer. This is how I get this answer in the number 3. Now we will proceed to number 4. As you can see here, I the net as you can see, the network address and the gateway address is almost the same. The only difference is the last value of the network address and the last value of the gateway address. So it's almost the same, like 192.168.10.0. Then when it comes to the gateway address is 192.168.10.1. So the same as this network address below, we just have to add one. I think we just need to add one to get the address address. So this is how I came up with this answer. I just add another one to the last number of the network address, so it becomes 10.10.78.129. So this is how I came up with this answer. Next, we proceed to number 5. So question number 5 is um, get the binary of the IP address. So we just have to use the network address, which is 192.84.235.0. So again, we could use a table To get the answer, use this table to get the answer, and use the number 5. Sorry, I just have to write the number for answer, which is there. Then we will proceed to number 5. Just need the um, binary value, the network address for to get the binary value of the IP address. 192.84.235.0, 192.84.235.0. Then space the table below. Second, can put 192 here, and then 84 and 235, 235, then a 0. Okay. To get the solution, we have to create table. Oh, so okay, we just need to subtract 192 to 128. So 192 minus 128. Sorry, I did not. Erase that. So 192 minus 128. Okay, so this will have divided. 1 from here to 12 minus 8, we have 4. And 8 minus 2, we have 6. So we have 64 since 1 minus 1 equals to 0. So we have the 64 value. So we could use this 64 minus 64. Then it is 0, so we don't need to use this number anymore. So I just put the value as 0. And then you proceed to 84. So 184. Then we just need to find a value that we could subtract here, since 128 minus 128, then we will put some 0 here. So we could use this since it's not higher than our value, which is 64. Then we could use this one. 84 minus 64. And we have 4 minus 4, 0. Then 8 minus 2. 4 minus 4 is 0. Then 8 minus 6, we have 2 value. So 20, we have a 20 value, so we just have to find a number that we could use to subtract on this. Since 32 is a higher number than our value, we cannot use this, so we just have to put 0. And we can use 16, since it's lesser than our value. 16 minus 20, then we have 4. Again, since we cannot use number 8, we just have to put some 0 here, and we can use 4 since it's equal to our value, so we just have to put 1. Sorry. 4. So 4 minus 4, we have a 0 value, and we don't need to use this number anymore, so just have to put zeros. Next, 235. So 235, we can use 128 to subtract with this. It's 235 value minus 128, then we have then minus 1. We have 2 minus 1, we have 0. Then 1, 2 minus 2, we have 0. Then since we borrow this number, then this we borrow number 1 from this number, so the value of this 3 is only 2. 2 minus 2, we have 0 now. 0 value, then 2 minus 1, we have 1. So 235 minus 28, 128, we have the value of 107. So again, we just have to put 1 here, and we could choose 64. So 64, 107 minus 64. Then we have 7 minus 4, we have 3. 10 minus 6, we have 4. Then we have the value of 10 minus 107 minus 64, we have the value of 43. So again, we can use these numbers. So 43 minus 32, and we have 3 minus 2, we have 1. 4 minus 3, we have 1. So we have the value of 11. So since we just only have the value of 11, we can not use this, so we just have to put 0 here. And we can use this since it's a lesser number than our value here. 11 minus 8, and we have 3. So since we have the value of 3, we can use number 4, so we just have to use number 2. So 3 minus 2, Then we have 1. Then again, since we have a body of 1, we could use this 1. So 1 minus 1, we have 0. So that's it. Then since this value of this network address is 0, we can't use this to subtract with this number. So we just have to put 0 here, and 0 here, 0 here, and 0 here, and again 0, 0 again, 0 again, and 0 again. So now we get the binary value of the IP address, which is 1100.001.01011.000.000. So far now we got 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, and 0, 0, 8, 0, above 2, 3, 4, 5, 6, 7, 8. And we have, this is how I get this number. Let's see, just see. It's the same. And we proceed to number 6. To get this broadcast address, again, we could use uh, the network address and the subnet mask to get the broadcast address. Just like number 2. So the network address for this is 192.84.235.0, and the subnet mask is 255.255.255.0. Again, since the value of the subnet mask is 255, 255, 255, every number of the subnet mask, which is 255, we just have to copy the value of the network address. So since it's the value of the first subnet mask is 255, then we just have to copy the 192 and the 80, and again, you just have to copy 84 and the 235. Since the value of the last subnet mask which is 0, then we um, then we don't need this anymore. Then we just have to put 255 here. So this is how I get the answer. The broadcast address, which is not 192.84.235.255. As the rule says, if there is 0 and the subnet mask, we ignore the value of the IP address, which is the 0, then just write down the 255 value. So as I said, if the subnet mask value is 255, we just have to copy the value of the IP address. Since we do right here, we copy the value of this IP address, and since the value of the subnet mask is 0 in here, we ignore that value and we just write down the 255. So this is how I get the answer for number 6. Again, we will proceed to number 7. To get the prefix length value and number 7, we just need to use the we just have to use the again the subnet mask and the table of 128. This table is 7. So so just have to copy the subnet mask for this number, which is 255.255.255.192. 255, so just erase this and replace it with 192. Since we all know that the value of the subnet mask in binary value is 8 ones, so I just copy copy from this table. Then we just have to solve for the 192. So 192, since 192 is higher than 128, we could use 128. So just put some 1 here. 192 minus 128, then we have 12 minus 8, 4, and 8 minus 2, then 6. Then 1 minus 1, we have 0, so I will not write down the 0, there's 64 in here. Since we have the value of 64, we could use this number 64 to subtract with our value, which is also 64. So 64 minus 64, then we have 0. So we don't need to use this anymore. Just have to put some 0 here, and 0 here, and 0, 0 again, 0 again. So we just have to count the ones and the value in the value of the binary IP address, since we had a 24 value already of ones plus this two ones, we have 24 plus 2, we have 26. So the value of the prefix 10 for this number is slash 26. So that is how I get this answer, 26. Now we will proceed to number 8. Again, to get the broadcast address, we just have to use the network address and the subnet mask. The network address for this number is 172.99.184.64, and the subnet mask is 255.255.255.192. Right. 172.99.84 and 184.64 and 172.99 and 184.64. 184.64. And so let's write down the subnet mask, which is 255.255.255.192. Again, to be able to get the broadcast address, since we have the value of the subnet mask, which is 255. As a rule C, we just have to copy the number of the network address, which has the value of 255 subnet mask. So just write down the 172 and 99.184 and last one. Since subnet mask value, the last subnet mask value is now 0, then we have to um, use the formula to be able to get the last answer for this broadcast address. Just in the table. So to use the formula to get the answer, when it could use when there is not 255 value for the subnet mask, we could subtract the value of the octet IP address to the number 256. So 256 minus uh, minus the value the value of the value of the last subnet mask, which is 192. 90. Then we have 6 minus 2, we have 4, then 25 minus 1, we have 6. 15 minus 1, we have 6, right? 6. The 1 minus 1, since we borrow 1 from this number, then the value of this is 1 minus 1. 1 minus 1, we have 0. Then 256 minus 192, then we have the value of 64. Since our value 64 is not greater than the value of the last of that IP address, we just have to so since we need a higher value than this one, have a higher value than this, let's have to add the value that we have. So 64, we have let's add the value that we have that higher than this but also closer than this. So 64 plus 64, then we have 68, 6 plus 6, 128. So 128, 128, we just have to subtract with 1, so we have 127. Oh, so the value of the last of that IP address is 12727. So this is how I get the answer for number 8, which is 172.99.184.127. And we'll proceed to to number 9. Get the binary value of the IP address. So to get the binary value of the IP address, we need the network address The value of the network address, which is 205.36.72.56. Number 9. The binary value, the network address is 205.36.72.56. I just need to copy the table. Copy this table. And put each value in this box was 205. Then 36. Even 2 and 5, 6. There. And just have to erase this. And we need the table. Now, get the number 205 minus 128. I could use 128 here. Then 5, 15 minus 8, we have 7. And 9 minus 2, we have 7 again. Then we have the value of the 77. Since we use this, we put the value 1. And also we can use 64 to subtract with 77 since it's a lesser number than 77. Then we have put 1. So 77 minus 64. 64. And we have 7 minus 4, we have 3. And 7 minus 6, we have 1. So we have the value of 13. Since we have the value of 13, we can't use this. We just have to put the value of 0. And also we can use this since it's a higher number than our value. And so we can use 8. Just put 1 here. Then 13 minus 8. Then we have 5. Since we have 5, we can choose 4 since it's not a higher value than 4 is not a higher number than 5. So we can choose for 5 minus 4. And we have 1. Since we have 1, we cannot value of 1, we cannot use 2. So I just have to put 0 here and we can use 1 here. So 1 minus 1. Then we have 0. And that's it. We'll proceed to number 36. 36. Since we have the value of 36 at the network address, We cannot use this, so I just have to put a value of 0 here, and 0 again here, and since it's 32, we can use this to subtract with 36 like this. Put the value of 1 here, so 36 minus 32, then we have 4. Since we have 4, we can use 16 or either 8. So we just have to put the value here at 0 and use 4. We could use this. It's 1. And 4 minus 4, then we have 0. And we won't need this. So I just have to number 2 and number 1. So put the 0 value here. And next, we proceed to uh, value of 72. So since we have a value of 72, we can use 128. So that's a 0 value here. And we can use this. This is a lesser number than our value 72. Just put 1 here. So 72 minus 64. Then we have 2 minus, 12 minus we have 8 and 6. So 72 minus 64, and then we have 8. Since we have the value of 8, we can use number 32. So we just have to put the value as 0 and also 16 as 0. Since it's a higher number than our value 8, and we could use 8. So just have to put 1. So 8 minus 8, then we have 0. Now we just have to, we don't need this number anymore, which is 4 to 1. So we just have to put 0 as the value for this column. Then we proceed to the last value of the IP address, which is 58. Network address, which is 56. So 56. Since we have the value of 56, we cannot use the number 128. We just have to put 0 here and also 0 here. And since 32 is a lower number than our value 56, we can use this. Just put the value as 1. So 56 minus 32, then we have a value of 6 minus 2 is 4, 5 minus 3 is 2. So we have the value of 24. Since we have a value of 24, we can use 16 because it's lesser number than our value. So it's 24 minus 16. Let's put some 1 here. Minus 16. 4 minus 6. 8. So 24 minus 16, we have 8. It is 8 this column. Then 8 minus 8. Sorry. Put some value of 1 here. Then 8 minus 8. 8. So 8 minus 8, we have a 0 value, so we don't need to use this number anymore, so we just have to put 0 as their value. Now we're done, we have the value of binary value of the network address, which is 100.001000000.0011100. So we have our binary value of the network address. So this is how I get the answer for number 9. Now we will proceed to number 10. So again, we just have to get the broadcast address, so we could use the again network address and a subnet mask. Just copy the network address and the subnet mask in here. Then and the network address for this number is 205.36.32.56. And the subnet mask is 255.255.255.248. 205.36.72.56 and 255.255.255.248. Sure. 205.26. Again, since the subnet value of the network address is 255, as our rule C, we just have to copy the number. The number value of the IP address at the outlet IP address, which is 205 and 36.72. Since the value here is not 255, we have to subtract it with 256. The formula of 256. So do the table to 2 5 6 5 6 minus 248. Now we have 16 minus 6, we have 8. We already remember one from here, so its value is 4. 0 and 4 minus 4, we have 0, and 2 minus 2 equals to 0, so we have a value of 8. 256 minus 248, we had a value of 8. So, so 8 is a lesser number than this. So we just have to add add again to get a higher value of 50, to get the higher value than 56. So 8 plus 8, and we have 16. So is 16 is a higher value than 56? So no. Then we have to add another 16 plus 8. Then we have 16 plus 8. And we have 24. So is 24 higher than value than 56? So it's no. So we just have to add another 8 until we get a higher number than 56. So 24 plus 8. And we have 32. Again, it's not a higher number than 56, so 32 plus 8, and we have 40. It's not a higher value than 56, so we add another more. This does 8, and we have 48. Again, it's not a higher value, so 48 plus 8 plus 56. So again, we have a 56 value, so just equal to this number. We need a higher value than that, so we just have to add another 8. 56 plus 8, and we have 64. 64. 64. So now we have a value of 64, which is higher than 56. So 64, so I have to subtract 1. 64 minus 1. Then we had a value of 63. So the last value of this IP address is 63. So this is the broadcast address. This is how I get